I'm Dr. Catherine Close, and today's chat is about chapter 5. So, in this chapter, we talked about data. What is data, right? Because I ended my chat on chapter 4 talking about data versus information. And this is really what our jobs are, taking a wonderfully designed AIS system, having a deep understanding, and using it to transform data into information. So data, it's facts, right? Statistics, they're collected for analysis and reference. So it can be numbers, words, measurements, observations, descriptions, and it can be what's called structured or unstructured. So a quick analogy of that, or example, excuse me, would be, you know, columns in an Excel spreadsheet with numbers. That's structured, right? A Wordle with all sorts of words all over it, right? That is unstructured data. And now we have the ability to work with both. In accounting, we're most often working with structured data. We're working with systems, software applications that we talked about that have underlying databases that we need to understand. So databases, they're a structure of logically related files or tables that contain data. And the thing we want to understand is there's relational versus non-relational databases, right? And the idea behind that is the idea that some are built where we have data in tables that share common references versus, so they share a relationship, versus others that may be what we call flat, right? That they're maybe just listed sequentially and that there isn't this overall pattern of references to other files and other tables. So a lot of early databases were these non-relational flat databases. So it would just process in order, right? And you'd keep processing and you'd keep going through the files. And when relational databases came out, and one of the ones you may already have had an understanding of is Access, right? Microsoft Access. And this is where we have these small tables and they become connected by keys, right? Which are simply common data that they share or that feeds into each other. So this is the whole idea, basically, understanding what kind of database structure are you working with in your system, right? And the other thing is, where do we draw some of this data from? Where do we store it, right? And this is where we get into the areas of the database itself, data warehouses, or data lakes, which is more unstructured. So database, you usually have pretty structured. A warehouse, you're storing all this data and pulling in reporting. And then the lakes are where we're looking at maybe word analysis and things like that. It's just more fluid. You don't have to have a deep understanding. Just know what these general things are. If you have a deep understanding, share it with us too, as we work our way through. So when we look at this, you'll see when we're talking about structured data, right? I mentioned Excel because it's numeric, text, date. It can be displayed in a table or a column. Can be displayed in a table or a column format. Requires less storage space, right? And it's easier to manage. If we're looking at unstructured, we're often talking about text, images, audio, video, and it can't necessarily be displayed in a table. It requires more storage space and it's kind of harder to manage. Some of the things you might see there, you know, a number is a number, it's going to go in a number field, right? An image, if it's categorized, right? And we'll say that's a landscape, that's a people, that's easy. But sometimes you get things in the middle, right? And you can't figure out, you know, so it's a little harder to make some decisions around that data. Some data can be static. It doesn't change. Some data is dynamic, right? It can be updated. It changes. It evolves. Most of our data today is uh, dynamic. When we work is dynamic. When we work with our databases, we are often performing queries or requests on them to look for certain data, to find certain data. And that's why understanding what your underlying structure is so important. A lot of these queries are written in certain types of programming languages, like the most common is SQL, which is SQL, right? We often call it SQL, and we write our queries on that. And then we pull the data out and we transfer it into different types of reports to make it more usable. When we talk a little bit about where we're keeping our data, the database, the warehouse, or the lake, I think one thing that's important to keep in mind is basically when we're thinking about where we store our data, right? The database, the warehouse, the lake. I think one of the things to keep in mind related to that is this idea of, is this real-time data, right? Or is this data that might have a lag in it? So a lot of times if you're going, you can query the database directly, like the accounting system directly, you're going to have real-time data. A lot of companies, though, have so much data that the data is moved from their system into the warehouse and users are accessing through the warehouse, and that may have a 24 or 48 hour delay, right? And generally that doesn't sound like much, but ironically, it could impact, you know, what you start to sometimes see is differences. You'll have a group of people that is working directly with the database, and then you have people who are creating reports from the warehouse, and somehow they get together and they're like, oh, that doesn't match, that doesn't match. So you have to know, like, whether your data, you have real-time access, real-time manipulation or not. Same thing with the lake idea is it's very open, it's very fluid, it's not filtered, right? Generally in its rawest state, you know, but when you're looking at something that's pulled from it, what filters did they use? So there already, we're getting into technologies on how we extract data, methodologies on how we extract data from where we store it. And it's important to have that understanding too. So what we hear a lot of is this idea of what's big data, right? What's big? We have so much big data now. So this is very, if we look at this qualities of big data, this is a very classic kind of concept now. One is volume, right? Two is variety. We have structured versus unstructured. The value of the data, right? Is it simply informational or is it key numbers, key figures, right? So the usefulness of the data when we extract it, how quickly does it accumulate or change, right? So this whole concept of, well, I queried the database on this day, right? I didn't, and it's different from what I have 2 days from now. This has to do with the speed of change or accumulation of the data and the veracity, the accuracy, and the truthfulness. Now, this is where our role comes in again as keepers of the data, right? And keepers of the accounting cycle and the accounting system. So big data has attributes of its own that tell us a lot about what we can expect from the data. And, you know, we always say a lot like, state your expectations or state expectations. Because once you know what the expectations are, then you have a better understanding if you're dealing, you can make evaluations. Well, is that accurate or not accurate? Oh, no, if there's a 24-hour delay, maybe something's happened. Let's go check that. Maybe we have to rerun the data. So this is why it's important to understand the qualities of data. So, having studied with students in the past on this chapter, actually one of the tougher areas that I hear about is when we dig into what are the elements of data, right? What comprises a data element? And later it will deal with the interconnection of tables and fields and things like that, which we're already seeing in our Excel pivot table work and our Tableau work, right? So let's review what elements of the data are. So first of all, we have a database. A database consists of files, records, fields, bytes, and bits. So you can either read this going down or read it going up, right? We collect bits. Through the computer, we're getting that binary digit, 1 or 0, right? This then becomes characters. Characters fill fields, right? Multiple fields become records. So, for example, this could be a record of one of our AR or AP, right? Partners, clients, partners, customers, and then multiple records become files, right? And multiple files become the database. So in this example, for the case that we've been working on, right, we're going to have multiple files or tables that are connected, and they may have intersecting fields, right? So within the payroll record, we may have employee and the department they work in, or within the department, we have a relationship between the employee and their pay. So these are the things we start to think about when we're thinking about the elements of data. And all of this is in the context of, what volume of data are we dealing with, right? And even for a small company, they generate considerable data. So how do we take this data and turn it into information, right? Well, a lot of it's done through our OLAP systems, right? Where we're performing analyses and we're gathering the data together. We're making interpretations. We have assured that the data is nice and clean and accurate because we're continually monitoring the data to make sure that our internal controls are reinforced and to make sure that it's accurate so we can pull it. And that's the job of our controllers, job of internal audit, and people who are responsible for the input and the curation of our data. When we pull the data out, we engage then in a type of analytics. So today, first of all, I want to say, that accountants and finance people have engaged in analytics forever, since the onset of the discipline. But we have in the past called it financial analysis, right? Or financial analytics. We've broadened the term today to business analytics, right? Business analytics is a set of disciplines that come together, right? So financial analysis, statistics, modeling, right? And other quantitative methods that we use to look for patterns in data, look for ways to perform what-if analysis, and to see what might happen under different circumstances based on the data that can then inform management on how to make business decisions. So business analytics is a subset of data analytics. Financial analysis is a subset of business analytics. And this is why you've probably, if you are preparing for the CPA exam, you've heard that business analytics is now part of the CPA exam. But have confidence, because we've kind of been doing this for a long time. So what we're going to do is we're going to go in, we're going to take this good and accurate data that we have taken responsibility for, and we're going to perform some analysis to tell a financial story. And that financial story can be about the solvency of the company, the health of the company. It could be how well the customers are paying. It can be how well our IT service desk is operating, right? But the big thing, so we are going to engage in different types of analysis, right? Descriptive. We're going to say what happened. And this is very much what we've done in accounting to date, right? When we do ratio analysis as part of our financial statement work or our annual report, we're saying this is what happened, right? Then we might dig deeper because we know we've learned that ratios are flags for us. They're flags for us to go in and check something out, right? So we do diagnostic analysis. Why did this happen in the past? Then we start predicting. Well, what would happen if this trend continued in the future? So we're starting to pull out this historical and move it into the future and say, you know, okay, if we continue on this track, this is what's going to happen. Excuse me. In that predictive stage, we start to get into what if. Well, what if this happens? Or what if this happens? Or what if we took it in this direction? And from that, we're able to engage in a phase called prescriptive analytics. How should we act in the future? What should we do? So the reason why we need to know about the elements of data is so we can engage in this continuous monitoring and auditing, right? To know if our data is good, to be able, when we perform analysis, right, to see if we see patterns or anomalies that raise flags for us, to see that we need to go back and revisit the data. And then when we have confidence, to be able to say, okay, now we can engage in business analytics activities that can help our managers solve problems. And once again, the visualization that we have down here in the corner for this IT, right? It's not an Excel table. It's a Tableau dashboard, right? Some of you ventured into dashboards in week one, right? You either know something about like a visualization software like Tableau that we're working with, or you know that management now wants to see a concise, nice summary of concepts, right? So on this dashboard for the IT, what are the key performance indicators of an IT service desk, right? Well, first of all, you know, tickets by status. We don't have a legend there, but it could be open, closed, whatever. By customer, right? If we have certain customer names. Are we getting a pattern with certain types of, is this a software call, an email call, a printer call? Why are they calling the service desk, right? Violations by month. This reminds me, you know, we're very, very good at MC about phishing and stuff like that, you know, so we'll get a report back. How many of us responded to a phishing email, right? I always get a giggle at that because usually I have responded to a phishing. Once in a while, I do that. And violations, right? Whatever their violations are. So this dashboard takes all the key performance indicators, pulls them together, right? This happens to be, we wouldn't necessarily call this accounting, right? But who's to say we couldn't bring in an element from the finance module and say cost to resolve, right? cost to resolve certain issues, right? Or something other that's important to various levels of management involved with the IT service desk. So this is kind of why we're looking at our software, our data, how we're pulling the data in, how we're monitoring the data, and then we're learning about what we can do with our data, because it's not just to produce financial statements, which is probably the last thing that last thing that is included in chapter 5 is a discussion between financial accounting and managerial accounting. And I'm not going to go deeply into that because you've taken both those courses, but isn't that the key, right? It's not all about producing external financial statements, and it's not all about producing financial information for internal use. We're serving multiple stakeholders in an organization, and we're providing data to many of them. So in our short summary of this chapter, we've looked at structured data, unstructured data, where that data is stored, who interacts with the data, right? What we then do to the data to get it in the state to use it and turn it into information, right? Have we cleaned it? Have we filtered it? Have we structured it in a way that's useful to us, right? Where are we, where do we have to store it in between, or can be it pushed out live? And then in the end, what type of activities are performed with the data or on the data, right? Do we have data analysts, right, in-house who are then working with business analysts? And do we share the data with other stakeholders in the organization? So that's chapter 5. We're going to continue this discussion and take it all the way through and continue to work on our special case so we can see and practice how we keep taking our data and turning it into information and telling the company's story. So I'll see you next time.